Hello everyone and welcome. In this video we're going to compute the integral from 0 to pi over 2 of log of sine of x times log of cosine of x divided by tangent of x dx. So we're going to denote this integral by I, just have something to refer to. Okay, let's get started. Okay, so the goal here is to use a change of variable and then use some polylogarithm functions. So first of all, we're going to rewrite log of sine of x as log of sine squared of x, and that's going to create a coefficient of 2. So we're going to divide by 2, and we're also going to replace log of cosine of x by log of cosine squared of x. It's going to create another 2, and then we have to divide by 2, so that's why we have the factor 1/4. And that's actually just the product, the power rule for the log function. Now what we want to do is rewrite 1 over tangent as cosine over sine, and then we are going to multiply the numerator and the denominator by sine of x, and also replace cosine squared of x by 1 minus sine squared of x. And we're going to end up with this. Now it looks a bit intimidating, but it's not really. So we're going to make a change of variable now. We're going to set that t is equal to sine squared of x. And of course, we're going to get some new limits of integration. We're going to get 0 for x equals 0 and 1 for x equals pi over 2. And of course, sine of x times cosine of x dx will be equal to dt over 2. Now, if we replace all of this, we're going to get 1/8 times integral from 0 to 1 of log of t times log of 1 minus t over t dt. Okay, now we're going to recall something here. So we're going to recall the definition of the polylogarithm function of order s, denoted by Li sub s. It is defined as a power series, so the series, the sum, as n goes from 1 to infinity, of z to the n divided by n to the s, which converges inside the open unit disk, centered at 0, inside the complex plane. And we have some properties of this function. We can clearly see here that LIS at 0 is going to be 0. But if we evaluate it at 1, we're going to get the Riemann zeta function evaluated at s. So zeta of s. Also, if we differentiate Li sub s, we're going to get 1 over z times Li sub s minus 1 at s. Now, in particular, if we replace s by 1, we're going to get negative, we're going to get Li sub 1 of z equals negative log of 1 minus z. And this will imply that Li sub 2 of z is equal to negative the integral from 0 to z of log of 1 minus t divided by t dt. So, and that term is exactly what we have in our integral. So we're going to make that function, the function Li sub 2, appear inside our integral. Well, the only way it can appear is as a derivative. So we can now rewrite the integral as negative 1/8 times the integral from 0 to 1 of log of t times Li2 of t prime. So that's the derivative of the dilogarithm function. Now we can integrate by parts. If we integrate by parts, we're going to get negative 1/8 times log of t times Li sub 2 of t, which we're going to evaluate from 0 to 1, plus 1/8 times the integral from 0 to 1 of Li sub 2 at t times the derivative of log of t. Well, the derivative of log of t is simply 1 over t. Okay, now let's evaluate log of t times li sub 2 at t at 1. Well, at 1, we're going to get log of 1, which is, of course, 0. So that term is going to vanish. But we cannot evaluate at 0, so we have to take a limit. Okay, so let's take the limit. And also notice that li sub 2 of t divided by t is simply the derivative of li sub 3 at t. So we're going to replace all of that. So I is now equal to 1 over 8 times the limit as t approaches 0 from the right of log of t times li sub 2 at t plus 1/8 times the integral from 0 to 1 of li sub 3 at t prime dt. Now we can just use the fundamental theorem of calculus on that integral. Now the limit, let's look at the limit. The limit is going to be 0 simply because the lowest power in li sub 2 at t is t squared. So t squared times log of t, if we take the limit, we're going to get 0. So the whole thing is going to vanish. In other words, li sub 2 at t is actually a little o of t. So if you take the limit, multiply by log of t, we get 0. So now we just have after integrations, so we're going to get li 3 at 1 minus li 3 at 0. Well, li 3 at 0 is 0, so the answer is going to be li 3 at 1 divided by 8. But li 3 at 1 is exactly zeta of 3. So the answer is going to be zeta of 3. And this is the end. Thank you for watching and see you next time. Bye.